This video is going to talk about reflections. We see a picture that has a line of symmetry, or it would if you could see the other half of the picture. You should be able to figure out, just by looking at it, how the rest of this picture should look when it's filled in. And it would be, something similar-ish to that, except it would be exact. When you want to draw the remaining half of the picture, a mathematician would say that you want to reflect the picture through the vertical line. The vertical line is called the mirror line. Can you guess why it's called the mirror line? The missing half of the face you will be drawing when performing this reflection is called the image. So what you can do is you can draw a line perpendicular to the mirror line through A. You're going to want to go ahead and draw these lines. We're going to go ahead and skip the activity and we're going to go on to something that looks a little bit different because this is difficult to show here. We're going to practice construction on these grids to show a mirror. Now, if you think about what happens when you're interacting with a mirror, as close as you are to the mirror, that's how close your reflection is. As far as you are from the mirror, that's how far away your reflection is, and it's a straight shot. So, if I look at this point and I want to reflect it across the mirror line, I need to see how far away is the point from the mirror. And this point ends up being 1, 2, 3, 4 points away, which means the reflected point will need to be 1, 2, 3, 4 points away as well. So we would put the point right there because it is the same distance from the mirror. As you get closer, it gets closer. As you get farther, it gets farther. So where would this line be reflected? Well, now we're not looking horizontally, now we're looking vertically. So let's go ahead and let's look, it's 2 steps away, so we would put the new point 2 steps away. So you could reflect the points to fill the coordinates of the images here. If I were to draw, say, an evergreen tree here, I would be able to redraw the same evergreen tree just by mimicking what had happened here. So I would be able to find the points. I have a point here and a point here. I have a point here and I have a point here. This point is 1 away, the other point is 3 away. This point is 1 away, the other point is 1, 2, 3, 4 away. And then we have these points right here. So how does this end up looking like the other side of the evergreen tree? Well, like this. Or, a whole bunch of arrows together. So, if I were to look at these points and I were to want to reflect them across one of the lines, in order to do that, we had a horizontal axis. So in order to reflect the points across the horizontal axis, what we'd want to do is we would want to keep the first number, to keep the x coordinate the same, because that's how far we ran. This is changing how far up or down are we jumping. So in order to flip and to find the reflected image, which for point A, we would say A dash, it would be basically a little apostrophe right there. And that would be still 2, but now -3. B dash, which is, in math we say it's prime, B prime, would be 4, -1. C prime would be -1, -4. Do you see how in all of these, I'm not changing the sign of the first number, I'm changing the sign of the second number. The reason I'm doing this is because I'm reflecting this across that same horizontal axis. So I want to change the vertical direction because of the way it's reflected. If we were going across the vertical axis, I would be changing the sign of the first number. So if I were to predict the coordinates of point 4, 3 when we reflect it through the x-axis, remember that the x-axis is the one that goes straight across, not up and down. If I were to graph point 4, 3, to reflect it across this x-axis, I would still run 4, but now I would be falling 3. So that would be 4, negative 3. So they want us to predict all these coordinates when reflected across the x-axis. All you would do for each of these is you would end up changing the sign of the y-coordinate. You know what, I think? Yep. It's difficult to do when you're not rewriting the whole thing. It's also time-saving. So we could sketch these out to see, but we're going to go ahead and keep going here. If we were to reflect something across the y-axis, the y-axis is the up and down axis. So if I were to take, let's say, point E, to graph point E, I would run 8 and I would jump 12. To change where E is going to be reflected across the y-axis, I need to run in the other direction. I need to run negative 8. I'm still jumping 12 because it needs to be at the same part in the mirror. So to reflect across the y-axis, you want to change the x-coordinate, or the x number. So that would find the opposite sign for the x values in each of these coordinates. Let's take a look and try to find points that are on the same line by seeing if they are reflected. So you might see that point A and point B both have negative 2, but one of them has negative 2, 3, the other has negative 2, 2. Those are not on the same line. If we look at A with 3 and B with 3, I'm sorry, they're on the same line, but they're not reflected the same distance. If we look at A and C, A is negative 2, 3, C is 2, 3. Do you see how the numbers are same and there's just that one sign that's flipped? That's because A and C have been reflected across the axis. Which axis were they reflected across? Well, they were reflected across the y-axis. We ran 2, we jumped 3. We ran negative 2, we jumped 3, which means that the y-axis here was the mirror. So they want us to reflect these points across the x-axis, then across the y-axis, and then to fill in the coordinates of the images. If I'm going to reflect something across the x-axis, I have to change the y number. If I'm going to reflect something across the y-axis, I have to change the x number. So in order to change both of those, we're going to change both signs. Point A prime would end up being negative 3, negative 4. B prime would end up being 2, negative 5. C prime, negative 4, 1. D prime, 1, 4. And E prime, 0, negative 3. Now, why didn't I change the sign for 0? That's because 0 doesn't actually have a sign, so there's nothing to change. If I'm reflecting something across a mirror, let's say I'm standing in front of, this is my mirror right here. I'm standing right in front of the mirror. Here's me. And standing in front of the mirror, I'm so far away from it. But if I put my hand right on the mirror, there's nowhere for it to go. The skin of my hand is touching the other skin of the hand, so it doesn't go anywhere. It's right there up on it. We're going to go ahead and go past that. So they want us to, yeah, no, that's just flipping. Ladies and gentlemen, I hope that your day is absolutely amazing.